How does groundwater recharge an aquifer? Imagine a rainstorm soaking into the earth, slowly filling up an underground water bank. That process is what we call groundwater recharge, and it keeps our water systems healthy. When rain or snow melts, the water doesn't stay on the surface for long. Instead, it begins to seep into the soil, moving downward through the layers of earth. This movement is called infiltration. The top layer of soil, known as the soil water zone, is where plants take up water and where some of it evaporates. But the remaining water continues to move down, pulled by gravity, until it reaches the water table, which is the top of the saturated zone where the underground water is stored. Once water reaches this level, it becomes part of the aquifer, which is like a giant underground sponge holding water for future use. How well this process works depends on several factors. For example, soils with large pores like sandy soils allow water to pass through quickly. In contrast, clay-heavy soils are less permeable, making it harder for water to infiltrate. Vegetation also plays a role. Plant roots can create pathways for water to enter the soil, but plants also use water through transpiration, which can reduce how much water reaches the aquifer. Surface conditions matter too. Urban areas with lots of concrete and asphalt cause more runoff, meaning less water infiltrates into the ground. Soil erosion can also reduce recharge by washing away the topsoil, which is vital for water to seep through. Sometimes, natural recharge is enough to keep aquifers full, but in many places, humans help out with artificial recharge. This involves directing excess surface water into specially designed basins or spreading water over permeable land to encourage infiltration. In some cases, water is injected directly into aquifers using wells, a process called artificial recharge. These methods are especially useful in dry regions or during droughts, helping to store water underground for later use. Planning artificial recharge projects requires understanding local geology, soil types, and aquifer properties. It's important to know how much water the ground can handle without causing problems like land subsidence or saltwater intrusion, especially near coastlines. Natural filtration through soil layers during recharge also improves water quality by removing pollutants, a process called soil aquifer treatment. Overall, groundwater recharge is a vital process that replenishes underground water supplies, supporting ecosystems, farming, and communities. Managing recharge effectively involves both respecting natural processes and using engineering solutions to keep our water systems sustainable and healthy.